Crewtone Ramone's How's the Math?
Is 5/5, which equals 1.
Yes. So correct. Right? Because 5 over 5, that's just the same thing as 1. I like it. And 4/5. Oh, so wait a minute. So you knew that 1/5 was the same thing as 0.2, right? Okay, watch. Look over here. Look over here. So if I want this to be 10, I have to multiply everybody by 2. And 2/10 and 1/5 are the same number. So over here, like I said, when you first started out, I was quite impressed. You said 8/10, because it is 8 of those and 10 of those. All right, because you just divide each one by 8, which is 4/5. But 8/10 really is the same thing as 8/10. Now let's talk about this thing for a second. Here's my decimal point. That's 1, right? This is 10. Now here's the thing. I can hear myself in the speaker coming through. Anyway, the fulcrum isn't right there. The fulcrum is in the place. So this is ones. Over here, this is tenths. And over here, this is tens. So the middle of it is actually here. We just put the decimal point, right? So here's the trick, young lady. Are you feeding him bananas?
No.
I have a lizard over here that eats berries. He's quite hilarious.
I see.
Well, no, because he's not a tame lizard like yours. He's a wild lizard, and he lives outside, and if I came over there, he'd run away. Alright, let's try another one. I think you're doing great, actually. I'm quite impressed. Like, I thought you were going to hum and haw about that one, but you got it immediately. Alright. How about 21/28? What's the one?
7/4. No, sorry. 3/7.
Oh, try again. You're there. 7 goes in a...
3/4.
It is 3/4. You're good. There you go. Got all excited there for a second. And why is it 3/4? Because times 7 times 7, and that's what you get.
1 divided by 7 equals
Yep, there you go. There's your 1.
Divided by 7.
Alright. Good job. Oh my goodness. What are we doing? We're just practicing multiplication, right?
Look at Shredder.
I know, he's huge. I can't get over how big he is. He was a little lizard that fit in your hand, and now he's as big as your arm. And he seems to be friends with you.
Yes.
He likes you. I can tell. Does Max have any strange animals for pets?
No. He used to have a baby frog. Like, he used to have fish.
Mm-hmm.
Then every night we would go to the fish store and buy different fish. Yeah, I was nasty about it.
I remember when he had a fish tank in his room.
So he had a baby frog.
He had a baby frog. I don't think a baby frog is quite as cool as Shredder.
Did the frog anything? So it died. I don't know. You might have finished stuff. I have no.
Okay. Alright. You ready for a toughie? Alright. I don't think I can give you a toughie anymore. I think you can do all of these. What should I do? Let's do 5. I don't know. 9 just for fun. What's the mixed number? Oh, sorry. The mixed number is 3 and 5/9.
Yeah.
What's the improper fraction? I know, you're looking at me like, what? Anyway, alright. 3 and 5/9 is the mixed number. What's the improper fraction?
It is. Wait.
Oh, wait. I'm waiting.
How do you make an improper fraction? Wait, you times the numerator by 3, right?
Wait a second. This times 3.
Oh yeah, you times 9 times 3.
Why would you multiply that? I know, because you're just doing a rule. That's why. All right, so let's talk about why this thing works. But anyway, do it.
Okay. 3 times 9 equals 27 plus 5 equals 30.
Oh, come on. What's 7 and 5 every time?
11.
Yeah, 4 and 7 is 11.
Oh, 12, sorry.
So what do I have?
It's 32.
It is. 32 over what?
5.
Why would it be 5?
Because the 5.
Were we counting by 5s or were we counting by 9s?
Sorry. Over 9. 9.
Alright. Alright, let's talk about this. See, because this is what happens when you just remember rules. This is exactly what happens when you only remember rules instead of knowing what you're doing. Alright, look. What if I have 5 over 2? We'll start small. 5 over 2. That's exactly what I have here. Alright, so what's 5 over 2? How many 2's in 5?
How many? 1. I mean 2.
2. 2. So if I count 1, 2, that means there's 2, and then there's 1 left over, right?
Mm-hmm.
So do you see now what I'm doing here? 2 times 2 is 4, plus 1 is 5, and I was counting by 2's. Right? Okay. So let's see here. Let's try again. What if I had something bigger? That was a small one. What if I had something like, oh, I don't know, 18 fifths. There you go.
$18.50.
18 fifths. 18 over 5. How many 5s in 18? Now see, because this is what happens. What happens is, every time I get to 5, that's 1, right?
Oh, so it's 3 and 2.
3 and how many?
And 2 fifths.
Wait a minute, what's 3 times 5?
3 fifths, sorry, 3 fifths.
There you go. Yeah, there you go. Gotta be able to do your subtraction. See, that's all we're doing is multiplication and subtraction. Now, see? This, what is this one? What's this name over here?
What?
This part, what's it called?
The denominator.
That is the denominator. What does the denominator mean?
5.
What does it tell? Well, okay, it means 5 in this case, but what does it mean in general? What's the denominator tell you?
It means how many pieces there are of the whole.
Okay, I like it. It means how many pieces there are of the whole, but it also tells you what 1 is. Right? Tells you that I've got 18 pieces, right? And they're 5s. But every time I get 5, that's 1. Because 5 tells me what 1 is. So there's 1, 2, obviously, because there's 2 5s and 10. 3, and then what you said, there's 3 left over, and we're counting by 5s. So I count 1, 2, 3, and 3 fifths. That's what that number means right there. And in order to go the other way, I have to take 5 times 3. Do you see it? The 3 of them. And then add the 3, and that's how I get to 18. And I was counting by 5s. It's not just some rule about multiply this by that and this, right? That's why. Do you see why? Your face doesn't say yes. Your face says no. Your face says maybe. Right? Because there's the 3 5s. That's what I was counting by. I was counting by 5s, and every time I got a 5, that was 1. And I had 18 of these things. You see? Yeah, okay. Now I like it. Like I said, the expression in your face says everything. Alright, are you ready for a toughie?
Yes.
Alright. We're gonna get all crazy over here. How about...
She's like laying next to me and she's like, I don't want to get crazy. I just
she does. Well, that's a lizard. You know what they like to do? Sleep and eat. That's what they like to do. And she's gonna get huge because she doesn't have to expend any energy or do any thinking. All she does is open her eyes and you feed her. That's why captive animals can't make it out in the wild, because they forget how to hunt and take care of themselves.
She knows how to hunt. Trust me.
Okay. How about... Let's just for fun. How about...
Like a beast.
7 and... Oh, there you go. We'll say 13 and 7 17ths. Ooh. Convert that. I'm already done.
Oh, yeah. Alright. 13 times 7 days.
What's 13 times 17?
100 and...
Try again. Try again.
I mean 221.
Yeah, 221. All right, I like it. So 221. Oh wait, I'd add 7. What am I gonna have?
What? And then 221 plus 7 equals 228 over 17.
There you go. I like it. Done. Look at you. Right? And see, that's what I mean. When you can do the multiplication of these guys, it makes life easy. All right. You want? Let's see if I can give you a toughy one. How about 16 and 5 19ths? Just to be pesky. What are we doing? We're practicing our 400 math facts. What's 16 times 19?
16 times 19 equals 211.
Wait a minute. I think we're gonna get to 300. What do you think?
I think you're right.
I think I'm gonna have 100. I think I'm gonna have 150, and I think I'm gonna have 54.
Which equals 304.
And then we add the 5, and what do we get?
359.
300
and 10. And
wait, 9. Just 9.
9.
Well, we're at 304, and 5 more is 309, right?
Oh no.
A little focus, a little less focus on Shredder, and a little more focus on your math would be good.
She licked my banana hand. I'll be right back.
Shredder licked your banana? Now you can't eat your banana because it's got lizard spit on it.
I'm going to throw it away.
I don't know, I don't think you and Shredder are so friendly that you can share spit. So yeah, probably a good idea to throw it away. Who knows what's in that lizard spit. Hey, did you hear about these guys? There's 3 of them. They were camping. And then they found them. They were all dead. It's a true story. And they couldn't figure out because there was no struggle. There was no anything. Campfire burned down. Looked like they were just having a nice cup of coffee sitting around the campfire. And all 3 of them were dead. Then you know what they found in the pot? In the coffee pot? They found a newt. You know, like how the witches... And it turned out that newt... gives off one of the more potent, I believe it's an alpha toxin. Anyway, so the 3 of them drank coffee of newt and they all died. And it was just a little newt, a little boiled newt. This is why you hear the story like the witch's cauldron and they put eye of newt or they put some newt in there when they're making poison, because never mind all the other stuff, the newt is bad. Alright, that's enough of that. Let's do something else. Yeah. What if I asked you this? What if I asked you a simple question? Which I want to see how you answer it. What's 1/2 of 2/3? Just think about it for a second. What's a half of 2/3? Just thinking. Look at here. Look at here. Oh my goodness, my things are totally messed up. Why is there a 1/6 in my halves? And that's all right. I'm not even gonna use halves. I can do that in a minute. But here, look. Do you see? Here's 2/3. What's half of 2/3? What's a half of these?
2.5.
Oh, stop it! What's a half of these? If I have 2 of these, I got 2 of these. Do I have? Can I easily split this up? Can you get 1 and I get 1?
Yes.
All right. So if I take a half, what's left?
1/3.
That's it. Why are you making this hard? 1/2 of 2. What's a half of 2?
Half of 2 is 1.
There you go. So 1/3. Done. Now you can do it the silly way, where I do 1 times 2 is 2, and 2 times 3 is 6, and 2/6 is the same thing as 1/3. But why not just take a half of a third and be done with it?
Because it's simple.
Yeah, I know. Too simple for you. I know. There you go. All right. Now, and I can also look at this. I can look at this another way. I can say, oh, these are dimensions. This says over 1 of 2. So here, look. I'm over 1 of 2. And then I'm going to be up 2 of 3. Wait, let me grab this one. Then I'm going to be up. So I'm over 1 of 2. I'm up 2 of 3. Now, here's the thing. If I do that, now I've got this, which is still harder. But do you see there's my 2 out of 6? But 2 out of 6 is still just the same thing as 1 out of 1, 2, 3.
Yeah, then.
Right?
The reason it's 2/3
Yes.
is because 2 is 1.
Yes.
And then the denominator is 3. So
Right.
it's 1/3.
So we're just saying take a half of whatever. Yeah, exactly. Take a half of 2/3. All right, let's get nuts. Are you ready?
We're gonna get crazy.
We're about to get crazy. We're gonna take a half of one that I can't do easily. Let's do a half of, say, like, ooh, let's do that. Let's do a half of 3/4.
Oh.
Now here's the thing. What's a half of 3?
A half of 3 is 1.5.
I know. So now we got this crazy thing over here. I can't say 1.5/4. That's not gonna work. So what do I do now?
You put 1.5 into a fraction. You put 1.5 into a whole.
Well, I could just take 1/2 of 3, and I could just do 3 of 8. Is that true? Is a half of 3/4 3/8?
It is.
It is. I like it. Okay, that's true. Am I done? Can I reduce or anything?
3/4.
No, I mean this part. Can I reduce 3/8?
3/4. No.
I can't, right? Because I'm already prime over here, and yeah, there's nothing more to do. If I was 2/8, I could reduce it. If it was 4/8, I could reduce it. Now let's think about this. I want a half of 3/4. Well, let's see here. Can you see? Let's talk about the 8 part. We're gonna make this into 8s instead of 4s now, right? Why are we gonna make that into? Why are we gonna make it into 8s? Well, 2 times 4 is 8. Now here's the thing. If I had 8s over here, pay attention. Wouldn't this be 6/8?
It would be.
It is the same, isn't it? 3/4 and 6/8 are the same animal. Alright, so let's take this and go like that. And say, oh look, there's my 6/8. In fact, you know what? I'm going to take this and I'm going to make that my vernaculum, or my solidus. It's straight, so. Alright. And now, look. I'm going to get all crazy and say, look, this is the same thing as 3 of those. Right? I have 6 of them. And down here, this would be 4 of them. Ooh, do I have 4 twos? I don't think I have 4 twos. Let's see if I have 4 twos. Do I? The answer is yes, I have some 2s over here magnetized. So then I'm going to just change these guys over here. Bam, 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 bam. Now, I've figured out that I can take, see, because I couldn't take a half of 3, but I can take a half of 6, right?
Yes, you could.
Alright, well, a half of 6 is just 3.
Exactly.
Alright, I like it.
3/8.
So it's 3/8.
Simple.
Simple, I like it. There's more I could do there, but I'm not going to. Let's see here. Let's do 3/4 and 3/4, which works out to 6/8. 6 to 8. But oh, that won't help because I can only take half of it. But anyway, how about how about 2/3? Let's, instead of doing 1/2 now, 2/3 of 5/9. There's a fun one.
Alright. So, you gotta figure out what 1/3.
Well, can you say I can just go, okay, I like it, don't fucking get back to 1, but at the same time, couldn't I just go straight across and just go 2 times 5 is?
2 times 5 equals 10.
And 3 times 9 is?
3 times 9 equals 27.
There you have it. So it turns out that 2/3 of 5/9 is 10/27. And I cannot reduce or anything. But think about it. What if I had 5/9 3 times? 5/9 once, 5/9 twice, 5/9 3 times. Right? Oops. Said, there you go. Alright. Look over here, So there's 5/9, 5/9, 5/9, right?
5/9 equals 59.
Right? And isn't, let's see here.
Equals 1 and 6/9.
Now here's the thing. Hold on a second. I would have 15/9 over here, wouldn't I?
Which equals 1 and 6/9.
I like it. Wait, what's 1 and 6/9?
1 and 6/9. It equals 1 and 2/3.
I like it. You're correct. That's the same thing as 1 and 2/3. Alright. Now, here's the thing. Oh, I'm not going to do that. So, that's a completely different problem, unrelated. What we're going to have is 10/27. Right? Okay. How about... Ooh. 5/6, which is almost 1. So we want almost the whole thing. So what would be 5/6 of... Pick a funny number. Pick a oh, actually any fraction.
9/10.
Oh, there you go. 5/6 of 9/10. Now here's something I can do just for fun, because of the way fractions work. Can I?
Oh, we cross off.
Yeah. How many 3's in there?
2. 2.
How many 3's in there?
3.
Let's see if it works. 5 times 3 is 15, and 2 times 10. Oh, look at that! And 2 times 10 is 20. Which would work out to 3/4, wouldn't it? 3 5s there and 4 5s there. Let's see if that's true. Let's see if it works. 5/6. This is still 9/10. We'd have 5 times 9 is 45. 6 times 10 is 60. Oh yeah. Can you see the 15s in there? That there's 3 15s there and 4 15s there?
Yeah.
Right? So I could just do the 15 thing. That's my 1. And I'm going to wind up with 3/4. That make sense?
It does.
It does make sense. All right, good. So 5/6 of 9/10 is 3/4. All right.
And we do that.
How about I do this? Because like I said, the main thing for you, practice your multiplication, practice your multiplication, practice your multiplication. Especially now, when it comes to these fractions, it's going to make fractions so much easier if you can just do your fractions easy, quick and easy. All right, now let's go totally nuts. What if I had a third?
Wait, Ben.
What?
Did you turn your camera on?
Yes. You're a little late in asking. Oh my goodness. Yes, it's been recording. It's been recording for. Oh, it doesn't tell me. I guess it does. I can't read it though. It's too small. But it's recording for over half an hour at this point. Okay, so let's see. I want to take 1/3 and I want to divide it.
36.
By, let's just take a whole number to start. 6. So let's say, what I just do with them. Seriously, what? Oh, right over here. All right. I got a third. But you know what? I want to take my third and cut it into 6 pieces. So let's say this is a third of a chiffon cake. That's all that's left in the pan. And I got 6 people. So now we're going to talk about the original cake.
So you do 1/6 of 30.
Yep, so I got to do 1/6 of that.
1/3.
I want to know how much each person gets, right? So they're going to get that 1/3. So what are they going to get? I'm going to take my 1/3. I'm going to cut it into 6 pieces. And each person gets that much. What's that? 1 of how many?
Each person gets 6 pieces.
Wait a second. I have serious issue with that answer. This is my third of a cake. I cut it into 6 pieces. How do I describe this one piece right here?
What? Hang on. Your amount? I can't hear you on that last.
Okay. How do I describe this one piece right here? What's this one piece called? This one right there. Just. Hold on a second. Oops.
It's called 6. 1/6.
It is. Is it 1/6? It's 1 out of how many? I think you want to change your answer.
1 out of 3.
1 out of all of these.
Oh, all of those.
Yeah. Yeah.
27.
Try again. There's only 3 6s there. Look, 1, 2, 3, 4, 5, 6. 1, 2, 3 times.
18.
So I'd be 1/18. Now do you see? They give you a rule, something about. Oh, here, I'll put it over here. 1/3 divide 6. Well, they tell you this rule about 1/3 times 1/6, and that this is the same thing, and that answer is going to be 1/18. Now, do you see why?
Yes, I do.
Let's think about it some more. Just want to show you that. All right, no, good.
Because
So-
1 times 1.
So I'm talking about the original cake, right? Here's my whole cake. Right? So let's say I have my whole cake here.
I just couldn't read it right.
Okay, no problem. No issue. Don't get upset. You were fine.
Am I doing
All right,
good?
so yes, you're doing fine. So here is the whole cake. So we went to a party, and 2/3 of the cake got eaten. Now you bring your cake home. Let's say it's in a big pan, and it's you and your mom and your dad and Max and a couple of friends are over there. Chef Carl and I don't know somebody else, and you all want a piece of cake. All right, so there's 6 of you. Well, I gotta bust. See, and that's the problem with this one. Can you see that those 6s are not even? Boo! Whoever cut this. You're a naughty person. Whoever cut this. All right. So anyway, these are supposed to be 6 equal parts, and that would be 1 out of the whole cake, right? 1 out of 18. All right. She's nodding. I get it. All right. Let's try another one. What if?
Then you, because you wouldn't like show. So I read it wrong. That's why.
Yeah. No problem. All right. Let's try again. Let's go with fourths this time. Let's say I had 1/4 of that cake left.
Yep.
And now I want, I don't know, let's take that 1/4 of a cake and divide it among 5 people. Now what?
1/4 of 18 divided by 5.
Yeah, so what am I going to do?
Alright, 1/4 of 18, that will...
Wait a minute, how am I getting 18? That's a 5.
Oh. 5/4?
So I've got 1/4. Wait, it's a new story. It's not the same story. So here's my new cake. This time I came back from the party, and instead of it having a 1/3 left, I only had a 1/4 left. And this time, instead of having 6 people that wanted what's left, we only have
4.
5 people. Well, 5 people. We're going to divide it among. So can I bust that into 5 pieces?
What?
Can I bust this into 5 pieces?
Yes.
All right, let's do it. How much does each person get? Can you see there? Well, let's cover this. Right there, they get that much. And it tells me, go over 1 of 4, and then, well, when I do the multiplication, up 1 of 5.
25th.
So they get 1 of how much?
25th.
How's that going to be 25?
Because there's 5 on each side.
But there's
Oh,
only...
no. I'm sorry, 16. 1/16.
Wait a second. What's 4 times 5?
20.
There you go.
Oh, now I get it. Okay.
So this whole...
Okay.
There you go.
1/20.
1/20th. Bingo. Yeah. Let me write that quickly. So that's going to be the same thing as 1/4 times 1/5. which is 1/20th. You see that? We're talking about this one little piece right down here in the corner. We're talking about that piece right there. You see? I don't know if you can see. Anyway, that guy. All right. That's why these guys come in actually pretty handy once in a while. All right, let's get crazy. What if I don't? Let's tell a different story. Let's take 1/5.
What if I get this one right? Can we quit early?
Sure, you've been doing great. You've been getting every answer pretty much, except for the last couple.
You heard that, Mom? Okay.
All right, you got to get this one right though before we quit.
All right.
All right, so let's say I want to take 1/5 and divide it among, and then I want to do 3/4. There you go. I want to take 1/4 and divide it into 3/4 pieces. Then what?
1/5. So wait, can you give that like example sheet thingy, whatever?
Alright, you want to see a picture? I see how it is. Alright, let's do it. I've got, so we can visualize this. I've got 1/5, but then I want to take 3/4 of that 1/5. I want to take that 1/5 and divide it 3/4 times. I don't even divide it a whole time. I don't want to divide it like by 2. I want to divide it by 3/4.
Yeah. So if you divide.
So I'm going to go over 1 of 5 and up 3 of 4. Wait, I got to get the right piece. Bam. Alright, there it is. So I go over 1 of 5. See it? 1, 2, 3, 4, 5. And then I go up 3 of 4. 1, 2, 3 out of 4. Bam.
So 4 times 5 equals 20.
There you go. But wait a minute, we got to invert and multiply first.
Yeah, 4 times 5 equals 20.
Yeah, alright. Well, that's the thing. I'm not going to do 4 times 5. Why not? Because I'm dividing it by 3/4. So before I can do this part, I have to do this part. And you're going to get a completely different answer. Now I can do it. Because I invert and multiply. The original problem was 1/5 divided by 3/4. But that's the same thing as 1.
Now I get it.
Alright, so then what?
So it would be. So you do 4 times 5.
Yeah. Oh, wait. 1 times 4.
1 times 4 equals 4.
And 5 times 3 equals?
15. So it's 150.
Yes. So now here's the thing. Here's how this works. Where'd my 1/5 go? There's my 1/5. So first I go over 1 of 5. Uh-oh, now I have an issue. How do I show this? Tell me.
How do you show it?
Well, this one says go over 1 of 5 and then go up 4 of 3. Well, like the 4, you got 3, but you're going up 4. So how do I show that? Well, I can't. How about that?
Three.
You see? I have 1 of 5, and then I have my 3s there. So I have, let's see here. I have 15, but I gotta go up 4 of 3. Uh-oh. So I'd have to actually go up an extra one. You see? And then I'd have 1, 2, 3, 4, the one that's up here that I can't see, 15ths. Or I could change my mind and just put that over here. And now I have 4 15s. But what I did is I went up 4 of 3, so I'd have to go up 1 extra one up here. So wait, I can draw it.
Yeah, please draw it.
I'm going to draw it. Here, you draw it with me. Have you got your whiteboard?
Hang on. Ah, Shredder, not on my blocks. Oh, we're heading from right. Alright, well, Shredder just laid on top of my blocks. So.
Okay. Alright, so 1, 2, 3, 4, 5. 1 of 5. And then I gotta go up. These are 3. I gotta go up 1 more. 1, 2, 3, 4 of those 3s. And just for fun, how much is each one of these?
Hang on.
How much is that orange one?
It's 1.
Out of how many? Don't count that one.
1/15.
1/15th.
Hang on.
I like it. And you'll have 4 of those 15s.
So now we have 4. Wait, isn't it 4/15?
Yes, it is 4 15s. That's correct. That's the correct answer.
You see? And I know I'm right.
And you know you're right. Now, I can sit around and we can talk about inverting and multiplying. Because what we're actually doing is counting how many times one number is contained in another number. And we can't do that unless they're the same.
Hang on. I'm working on some serious whiteboard erasers.
Alright, get your whiteboard picture together. And then we'll quit. Although I'm going to do one more thing before I quit, because I just want to make it drive the point home. Why do we invert and multiply? It's just a shortcut.
Wait, what?
We gotta make our numerators the same before we can count. Or excuse me, we gotta make our denominators the same before we can count. Because the numerators tell us how many of what kind, and 15 tells us what 1 is. Tells us the whole thing.
Okay. Wait, what?
Well, here's our picture. Let's see your picture. Yeah, I said that wrong. The numerators, we don't care about the numerators. It's the denominators that have to be the same.
Hang on, I'm gonna get a paper towel. I'll be right back.
Okay. I love it. Shredder's just sitting there. He's thinking about licking another one of your bananas, I can tell.
She loves fruit. I just realized that she loves strawberries.
Strawberries?
Yeah.
Wow. See, that's a good thing. You can feed them crickets and stuff, but I think maybe once in a while some fruit would be good. I wonder if they eat seeds.
I don't know.
Me either. Alright. You got your picture drawn?
Yeah, I'm still cleaning my whiteboard. And because it was very dirty. It was very. So I draw a picture of that. What color shall I draw it in?
Whatever color you like.
Red or green or black?
Go with black. And then you can color one of the squares in with red. Because here's the other thing. If you just remember a rule, I've seen kids get confused and invert that one.
And roll all the way over. There we go.
And then we have one more thing. Because really, that's what you're doing. You're going over 1 of 5, and then you're going up 4 of 3. But you only had 3, so you had to go up 1 extra one. That's why, once you understand the symbols, the numbers just tell you what to do. Here's your instructions. Go over 1 of 5, go up 4 of 3. And you wind up with 4 of 15. Oh, and I was going to ask you, what was bigger? Wait, what are you doing?
Alright, I'm done.
I know, you're taking an inordinate amount of time. Oh, no, alright, I like it. What does it say? Math what? Math rules.
Rules.
Math does rule. I like it, very good. Now, the only thing I'd like is some symbols. Your picture is perfect. So just put 1/5 times 4/3.
Alright.
But your picture is exactly correct. Survey says. Ta-da! Very good. All right. That's exactly what you did. All right.
Let's go.
I say we can quit, but I want to do one last thing.
Alright, what is it?
The last thing I want to talk about is that, look. If I have, let's say I want to take 5. Anyway, I want to take 3 and divide it by 5. That says how many 5s are contained in 3. Right?
Yep.
Are there any 5s contained in 3?
No.
No. Alright. So 3/5, we can already tell that's less than 1, right? Because there's less than 1 5 contained in 3. Okay, now what if we did with fractions, though? Let's say I want to count how many halves are contained in a third.
How many halves are in the third?
Well, once again, I can't count halves out of a third because a half is bigger than a third.
It is 1/3, 1/2 of a third.
Alright, so here's what we have to do. We're going to make them same. Can I make them same? What's a common denominator?
6.
I like 6. So if I do this into 6, if I make this 6, this makes this 3/6, right? And if I make this 6, that makes this 2/6.
I'll be right back.
Alright. She had to run to the bathroom, that's funny.
I had chemicals on my hands and I didn't want to pet Shredder with
Yeah, it's a
them.
smart idea to wash your hands. Because, yeah, the animals are more susceptible to the chemicals. You should probably not put the chemicals in your hands either. If you don't want to touch your lizard with chemicals on your hands, maybe you shouldn't put chemicals on your hands at all, because probably the chemicals in your hands aren't any good. Just saying.
Yeah, no, I just used this on the
Yeah,
light.
I don't, yeah, take it easy. That's mostly alcohol, so it's not that dangerous, but still. Alright, look over here. So, all I said is, look, I want to take 1/3 and divide it by a half.
Yep, 1/3 divided by a half.
And that's just going to be the same thing as 2/3. Because I invert and multiply. Oh look, there's 2/3. Oh look, there's 2/3. Do you see it?
Yes, I see.
So now I can see that, look, that's the same thing as 2 divided by 3. It's the same thing. It's just a shortcut. That invert and multiply thing, it's just a shortcut. Because I know that right now when you're doing fractions, you're doing addition and subtraction and multiplication of fractions. And they always say division for last. Alright, let's call it a day.
Alright, so long.
Alright, so Crewtone Ramone's houseofmath.com. What did you say? Like and subscribe.
Subscribe.
Alright, and look, I got another class right on top of you. Alright, we'll talk to you soon. Alright, bye. Crewtone Ramone's houseofmath.com for more.